It's chemistry and you are watching Damn Science.
In this video, we are going to discuss 9701 Chemistry A Levels question paper 52 of the examination series Feb-March 2024. So let's start with question 1 here. It says seawater contains about 20 gram per dm cube of chloride ions. That is, seawater is containing chloride ions in aqueous forms, and the exact concentration of chloride ions in seawater can be determined by titration with aqueous silver ions, that is Ag plus ions in aqueous form, using potassium chromate 6K2CrO4 as an indicator. And you can read pause the video and read the whole process where how the reaction occurs, and the silver nitrate in Ag plus form is reacting with chloride ion to form the precipitate of silver chloride, and the excess silver ions reacts with the chromate indicator to form AgCrO4, which is again red precipitate. So that acts as an indicator where the reaction is over, the chromate will react to form this showing red color. So the end point will be a red color. So here is the process given where a student uses the following method, and step 1 says use a weighing board to weigh by difference approximately 10.6 gram of silver nitrate into 10 centimeter cube of glass beaker. So what are we doing? We are weighing approximately 10.6 gram of silver nitrate in the weighing board, and we are passing it into a 100 centimeter cube glass beaker. Use the sample of silver nitrate in the glass beaker to prepare 250 centimeter cube of silver nitrate. So what we are doing, we are weighing this much of silver nitrate and dissolving it in water to make a 250 centimeter cube solution. Transfer this solution in a dark brown glass bottle. Label this solution as X. Now collect a sample of seawater and remove any solid materials present. Transfer 10 centimeter cube of seawater in a conical flask. Add 1 centimeter cube of potassium dichromate to the conical flask. Rinse the burette in the preparation of the titration. Fill the burette with the solution X. Now what is our solution X? X is a silver nitrate solution. Slowly add the solution X to the conical flask until white precipitate turns red. This is the end point. So this is the process where we are using titration for the calculation of silver ions, which silver ions in turn will give us the concentration of chloride ions. So describe how the student should carry out step 1. Include a table in your answer to show how this process is recorded. Now what is step 1? If we have a look, it says use a weighing board to weigh by difference approximately 10.6 gram of silver nitrate into 100 centimeter cube glass beaker. So in step 1, we are actually weighing 10.6 gram of silver nitrate with the help of weighing board. Now if you look at the question here, it says describe how the student should carry out step 1. Include a table in your answer to show how this process is recorded. Now when we talk about word describe, you need to describe the steps by which the process should occur. So step 1 is weighing of 10.6 gram of silver nitrate. So what are we going to do is weigh the board and add approximately 10.6 gram of silver nitrate to it, and weigh again and record the weigh and record. Transfer silver nitrate to beaker and reweigh the empty boat. So this is how we are going to do the whole process, and we'll find the difference of the boat plus silver nitrate and the empty boat to actually find out how much of silver nitrate is transferred to the beaker. So if we make a table here, you need to use a scale to draw a table. We'll write here the content, we'll write weight in gram. We'll first write weight of boat plus silver nitrate. So that's how we are going to note the first one. Then the next one is empty boat weight, and then the mass of silver nitrate. So if we find the difference of the above two, we'll get the mass of silver nitrate used, which is approximately going to be 10.6 gram, but after weighing this, we'll exactly get what is the mass. Maybe 10.59, 10.61, but then after weighing, exact mass will be determined, and this is how we are going to do it. The next question is describe how the student should prepare 250 centimeter cube of silver nitrate in step 2, starting with the silver nitrate in 100 centimeter cube beaker in step 1. So if we again describe the steps here to prepare the 250 centimeter cube of silver nitrate, which we have weighed in our earlier step, what are we going to do is, we have already transferred the silver nitrate in 100 centimeter cube of beaker. So what are we going to do is add small amount of water, or you can write small volume of distilled water. Be specific here, distilled water has to be used. So small amount of distilled water to the beaker and dissolve the content and dissolve it. So we are going to dissolve the silver nitrate which we have added in the beaker, and after dissolving, transfer the solution. Now the solution which we have prepared is 250 centimeter cube. So transfer the solution in 250 centimeter cube of volumetric flask, because volumetric flask is the apparatus which we use to prepare the standard solution. So 250 centimeter cube of volumetric flask we are going to use. We also have to say that rinse the beaker and transfer the washings also. Transfer the washings to the volumetric flask. Now after doing this, we are going to add distilled water up to the mark. So we can write here the last step, add distilled water to the flask till the mark and shake well. So this is how you're going to describe the whole formation of making of silver nitrate solution with the help of volumetric flask and the solid silver nitrate which we have weighed in our earlier step. Now question C says, suggest why the solution X is kept in a dark brown glass bottle in step 3 rather than a colorless glass bottle. Now whenever we are using dark glass bottle, that's only because the sunlight may affect the compound which is present inside. So here if we are using silver nitrate, it's because silver nitrate can decompose in presence of sunlight, or light, in presence of light. So this is how we are going to protect it from light by keeping it in a dark glass bottle. Suggest how solid material should be removed from the sea water in step 4. It's a simple process that will use filtration to remove any solid material which is present in the sea water before we use it for the presence of chloride ions. The next question is, identify the most appropriate piece of equipment that you would use to transfer 10 centimeter cube of sea water from the dark brown bottle to a conical flask in step 1. We are going to transfer 10 centimeter cube of sea water from dark brown bottle to a conical flask in step 5. Now what is step 5? Let's have a look. Step 5 says transfer 10 centimeter cube of sea water into the conical flask. Now if we are transferring 10 centimeter cube of sea water exactly to the conical flask, we're going to use a volumetric pipette of 10 centimeter cube. So we'll write here volumetric pipette. We don't need to specify the volume because it's already written here 10 centimeter cube. If it's had been 25 centimeter cube, then we'll have to use the volumetric pipette of 20 or 25 centimeter cube as mentioned here in the volume. Now add 1 centimeter cube of K2CrO4 aqueous to the conical flask in step 6. Now this is an indicator, it need not to be exactly as the same volume. So here you can use the dropping pipette or you can write it dropper also, but I prefer writing drop pipette because it's not just a small pipette, it's a longer pipette type. So here we write it as a dropping pipette. Now the next question is chromate 6 solutions are known to be carcinogenic. State what precautions should be taken when using chromate 6 in step 6 other than wearing safety goggles. Now if any solution is carcinogenic, obviously we need to keep it away from our body, and so to keep it we need to wear an chemical resistance gloves. So wear chemically resistant gloves. We need to specify here chemically resistant gloves because there may be difference in the gloves which we use, so here we need to specify it. Question G is state what the burette should be rinsed with in step 7. Now burette we using solution X to fill with. We are using solution X. We are filling the burette with solution X. So rinsing also has to be done with solution X before we actually start the preparation so that the concentration of solution X does not change during the process, during the titration. So we rinse the burette with any solution which we are using for the titration. Now here in question H, the student obtains the results shown in table 1.1, and here is the titration readings which we have taken is final volume, initial volume and titer in centimeter cube. All the first one is rough titration, titration 1, titration 2 and titration 3 here is given, and the sub question is complete the table 1.1. So the first difference here is obviously 23.40. The next difference here is 22.35. Here the difference is 22.60 and the last one is 22.45. Let's go ahead with the next sub question. It says calculate the mean titer to be used in the calculations show your working. Now if we have a look at the readings, we generally don't include the rough titration in our mean. So if we have a look at titration 1, 2 and 3, you can see that titration 2 is quite different or have a big difference compared to titration 1 and titration 2. We generally call such titration which are very close in the reading are called concordant readings or concordant titers, which need to be very close and they are supposed to be used for the calculation. So here titration 1 and titration 2 are close enough with the difference of only 0.1, which is considered as concordant reading, and the mean of these two only have to be taken. The titration reading which are much different or are far off from 0.1 difference are not considered generally. So here we are going to use only titration 1, titer 1 that is 22.35 and titer 3 that is 22.45 for our mean calculation only. So this is how we are going to calculate the mean. And the answer for this is obviously 22.40 centimeter cube. Now let us make one more point here is that all the titers readings has to be written with the 2 decimal places. although we generally find burette with the decimal place of only 1, but as we can see that there are few readings with 0.05 also, so we need to write our titer, mean titer, and the titration differences here also with the 2 decimal places. This is how I generally keep on telling my students to be careful of, because such marks are also considered, such points are considered while marking your answers. The next sub question says here is that use the mean titer from H2 to calculate the concentration of chloride ions in the sample of sea water. Assume the mass of the solid silver nitrate used in step 2 was 10.62 grams. So here the mass used with the weighing boat difference is 10.62 gram here, which is already given here. So if we want to calculate the concentration of chloride ions, first we need to calculate the concentration of silver nitrate and the moles of silver nitrate. So starting with the mass given here, we can calculate the moles of silver nitrate here by dividing the mass by its atomic mass, that is ARs, which is 169.9. You can calculate it from the periodic table also, which I've already given here, and so the number of moles used of silver nitrate is 0.0625 moles. Now once we have got the moles of silver nitrate, what are we going to do is that silver nitrate moles, what we have calculated here is present overall total in 250 centimeter cube volume. Total solution which we have made of silver nitrate is 250 centimeter cube. But here our titer of silver nitrate is 22.40. So if we want to calculate the moles of silver nitrate which is reacting with moles of silver nitrate reacting with chloride ions, because this is what we have got in titration, then we have to cross multiply, and if we cross multiply, then our answer is 0.0625, which is the total moles in 250. So how much in 22.40? So this is how we calculate, by dividing it by 250 and multiplying it by the titer which we have got in the upper question, that is second sub question. And for the answer for this is 5.60 into 10 power minus 3 moles. So this is how we get the moles of silver nitrate which is reacting with chloride ions, because this is what we get from the titration. Now if you want to calculate the concentration, see again have a look at the question. What are we supposed to calculate? Concentration. So here we have got just the moles of chloride ions. So if we have calculated the moles, we need to calculate the concentration, and concentration can be calculated by dividing moles and volume. So moles is 5.60 into 10 power minus 3 divided by the volume which we have used for the sea water, and which was 10 centimeter cube, but 10 is centimeter cube and we need to divide it by 1000 to convert it into dm cube. So if we do this, we get the answer as 0.560 moles per dm cube of concentration. Now you can see that I have written it to 3 decimal places. Writing our answer to 3 decimal places is very important when we are showing such a calculation. So the concentration is calculated here. What we first did is the moles of silver nitrate we calculated by what we used in the preparation of the 250 centimeter cube of solution. So the total mass divided by its atomic mass, we got the moles which was present in the whole of 250 centimeter cube which we had prepared. Out of that, only 22.40 is our titer which is used to react with the chloride ions. So from that we calculated by cross multiplication that what were the moles present in our titration, in our titer volume. From that we got the silver ions moles. Now we can look at the equation that Ag plus and chloride ions react with the 1:1 moles. So moles of silver ions is equal to the moles of chloride ions, and that's why to calculate the concentration of chloride ions we use the same moles which we had calculated for silver ions. So those moles is equal to the moles of chloride ions. So moles of chloride ions divided by its volume of seawater, in which we are supposed to find the concentration of chloride ions. So the volume of seawater used, you can check these steps. What volume of seawater which we had used? It was 10 centimeter cube. So moles divided by volume is the formula which we used. Moles of silver chloride ions divided by its volume of seawater, and we got the answer as concentration of chloride ions. Now here its next sub question says calculate the percentage error in titration 2. Now whenever we are using the titration, our burette reading is read to 1 decimal place only. So what is the maximum error of any burette reading which is showing our reading minimum to 0.1 is 0.05. You have to divide this by 2 because 0.05 is the reading which our burette cannot read. So this is the maximum error. And to calculate the percentage error, we should multiply this by 2. Why? Because in the burette, we read the reading twice. First is the initial reading and second is the final reading. So the error which we used, the error which we came across is twice. Because we read the burette reading twice, so the maximum error is also used twice. So we have to multiply the maximum error with 2 and then divide it by the reading of what we are supposed to calculate the maximum error. So titration reading 2 was 22.60. So divide it by 22.60 into 100. So this is how we calculate the percentage error, and the answer for this is 0.442%. So this is the percentage error of our burette reading titration 2. So this is the percentage error. Okay, the last sub question is spectroscopic analysis of the sample of seawater accurately determine the concentration of chloride ion to be lower than that determined by titration with silver aqueous. Okay, suggest why the student's method gave a higher volume. Now if we look at the method which we have used, is actually we calculated the concentration of silver ions which reacted with the chloride ions, and that gave us the concentration of chloride ions. Now if the chloride ion actual concentration is lower, that shows that some excess silver ions would have reacted but not with chloride ion. So if silver ions have reacted excess than the chloride ions, that shows that there must be some other substance also present in the sea water with which the silver ions are reacting. So suggest why the student's method gave a higher volume. So this is a reason. So what we can write here is that the silver ions react with other ions present in seawater. So that's why the concentration of silver ions calculated was higher, and so we found the chloride ions concentration also higher. Actually it was lower. So this is the reason how we will write, and here the question 1 ends. Now let's start with question 2. Question 2 says a student wants to investigate rate of hydrolysis of methyl methanoate, and here is the equation given where methyl methanoate on hydrolysis produces methanoic acid and methanol. The reaction is catalyzed by dilute hydrochloric acid, that is one of the acid is present as a catalyst. Now amount of methanoic acid produced as the reaction progresses can be monitored by titration with the aqueous sodium hydroxide, that is NaOH, of the known concentration using thymolphthalein as an indicator. Now to determine these, the volume of NaOH needed to neutralize the hydrogen ion from the catalyst. Now we have used HCl as an acid, as in catalyst. So hydrogen ion present from the catalyst will also react with NaOH, which we are using for the titration. So again we need to know that NaOH required for neutralizing the catalyst is what volume, and that can be determined beforehand before the titration. Okay, so the student uses the following procedure, and here are the steps given. You can always pause the video and read it. It's all about the titration where, but let me summarize here. It's approximately 150 centimeter cube of iced water to a 250 centimeter conical flask A is added, and then add 200 centimeter cube of 0.250 moles per dm cube hydrochloric acid to 500 centimeter cube of conical flask B. Now understand, this is the conical flask B, which is a bigger one, and there we have added hydrochloric acid, which is needed as a catalyst. And conical flask B is the flask in which the reaction takes place. So actual reaction which the hydrolysis will take place, that will be in conical flask B. Okay, so transfer 2 centimeter cube of 0.250 hydrochloric acid from B to conical flask A and carry out single titration of the contents of conical flask A with NaOH of the known concentration, and then the procedure goes on. And in the last step, it's written repeat step 6 at the intervals of 10 minutes for 1 hour. Pause the video and read each and every step, where it's very important to read and understand the procedure. Okay, let me go ahead with question or sub question A. State which step is used to determine the concentration of hydrogen ions from the catalyst in the mixture. Now why did I read the first few steps? Because of the same reason. So let's check what is this done here. You can see that initially in conical flask A we added only 2 centimeter cube of hydrochloric acid and carried out the titration with NaOH. So this is the step where we are trying to find out the concentration of you can say concentration is already given, but what volume of NaOH is required to neutralize the acid. That is the titration done for the first titration, because you can see here the methyl methanoate, the ester is not added in the titration done in step 3 here. So our answer to sub question A is step 3. Step 3. Okay, let's go ahead with step B. Sub question B. It says the iced water in conical flask A is used to significantly reduce the rate of reaction. So what are we doing? We are adding iced water in step 1 in conical flask A. This is used to significantly reduce the rate of reaction. Okay, so suggest 2 reasons why the rate of reaction is significantly reduced when the reaction mixture is transferred to conical flask A. Now in the conical flask there is iced water, and if we are adding the reaction mixture in the flask A, then obviously the rate of reaction will be reduced, and the reason one is that the temperature decreases. Now as we know, as the temperature decreases, the rate of reaction decreases. So we can write temperature decreases, rate decreases. That is how we can write it in short. You can write it in full also, that as the temperature decreases, the rate decreases. And the second reason is that we are adding a lot of water. Now if we are adding, then obviously it becomes diluted and the concentration decreases. Now another reason is that if the rate decreases, one of the reason can be the concentration decreases. So we can write again here as concentration decreases, as concentration decreases, the rate decreases. As concentration decreases, rate decreases. These are the 2 reasons that the rate of reaction decreases in conical flask A where iced water is added. Now let's go ahead here. We can see that Table 2.1 shows the readings taken by the student here. So here is the table 2.1 where the readings are shown. The titration in steps 4 to 7 shows the volume of NaOH needed to neutralize the hydrogen ions from the catalyst HCl and from the methanoic acid produced in the reaction. Now volume of NaOH needed in centimeter cube to neutralize H plus from catalyst is 11.40 centimeter cube. In the next step, it's written volume of NaOH in centimeter cube used to neutralize hydrogen ions from methanoic acid at time t is Vt. That's given by Vt. And the volume of NaOH in centimeter cube used to neutralize hydrogen ion from methanoic acid at 60 minutes is given by V alpha. So here it's given and the table is given fully here. Now student forgot to take reading 5. Complete the table 2.1. Now table 2.1 is Vt. Vt is what we need to find out as the volume needed to only neutralize the acid hydrogen ions from methanoic acid. Now you can see that in the second column the heading says total volume of NaOH needed to neutralize the total amount of hydrogen ion. The total amount of hydrogen ion means addition of this and this, because the acid is also present as a catalyst and acid is also present as one of the product. Total volume of NaOH needed to neutralize both of this is given here. So if we want to find out Vt, we have to subtract 11.40 centimeter cube from the volume given here. So after subtraction we have to write. So here we have to subtract 11.40. And the same subtraction has to carried out for the remaining readings also. So I've already done it for you where I'm subtracting 11.40 from each of the readings given here. I have written Vt, that is the volume of NaOH required to neutralize only one of the product methanoic acid. And now the second column in the table is V alpha minus Vt. Now what is V alpha? That is the volume of NaOH needed to neutralize the hydrogen ion at 60 minutes. Now what is the volume of hydrogen ion of methanoic acid at 60 minutes is 14.50. So that is V alpha. And now what we supposed to do is that we have to subtract V alpha minus Vt in centimeter cube. We have to written. So from here also we have to the first will be 14.50 minus 1.20. That is what we are going to do for the last column, and that will be done for all the readings. So now I have completed the last column also by subtracting each of the values from 14.50, that is V alpha value, that is Vt at 60 minutes. And so now our table is completed. So let's go ahead. What is written here? Identify the independent variable. Now if you check one of my another video which shows the examination tips to paper 5, there I have explained each and every variable. What is independent variable? What is dependent variable? What are the controlled variables? Here let me just tell you in short. Independent variable is the one which we change during our reaction. Now what are we changing at during the reaction? You can see here that what are we changing is the time. Time is changed and the volume of NaOH used for each minute after the reaction of those particular minutes that is measured. So identify the independent variable. So what are we changing? We are changing the time. What are we changing? We are changing time, and we are measuring the rate with respect to time, that after few minutes, every few minutes, how is the rate changing? That's what we are measuring. So independent variable is time. Identify one variable that needs to be controlled apart from the concentration and volume of solutions. Now one variable that needs to be controlled means what factor we're going to keep same throughout the experiment. And they've already given two, that is the concentration and the volumes of the solution. Every time we are keeping same. So other than that, we are keeping the temperature same, because neither we are heating nor we are cooling it after every certain time. So temperature we are keeping constant throughout the reaction. Now the fourth sub-question says reading 2 should have been taken at 10 minutes and not at 13 minutes. State whether this result should have been included or not and explain your answer. And my answer is yes, we can include. The reason being is that if we would have taken the reading at 10 minutes, the reading would have been little different, and if we are taking the reading at 13 minutes, our reading is different, that which is relevant to 13 minutes. If we take the reading at 10 minutes, the reading or the title will be relevant to the 10 minutes, so that doesn't make any difference. The rate will go on as such. What is going to happen, it's independent of time. So time actually, whether we measure at 10 or we measure at 13, doesn't make any difference. So what we can write is yes, we can include these title at 13 minutes rather than 10 minutes because the value of title is correct with respect or corresponding to the time, with respect to its time, and we don't find any inaccurate or invalid reading because the pattern, the trend keeps on going as such. There is no change or no disruption in the pattern of the reading. So yes, it can be included. Now in the next question, we can see that here there is plot a graph on the grid in figure 2.1 to show the relationship between V alpha minus Vt and the time. Use a cross to plot each data point. Draw a line of best fit. Now we can see that the grid is not fitting our screen, so I'll use it a smaller grid in the other screen and I'll show you how to plot it. And now you can see here that I have shown you a grid in smaller version, and I've also plotted a points, all the points with crosses on the grid. And now we can draw a best fit line, and looking at the points you can easily make out that the best fit line will be a curved line. So now let's make a curved line for this, all the points. And here is a best fit curve. Now you can see that as I'm drawing it on the screen, the curve is not perfect, but when you draw with a scale on a paper, it can be a perfect. It should not be a zigzag line because it's written draw a smooth line graph, a smooth line of a best fit. So it should go very smoothly, not the zigzag one. But yes, this is how it should go, with a curve going down. And as it's a rate of reaction, you can always remember that when we plot a graph of concentration or volume against time, in rate of reaction, the graph, the line of best fit should always be a curved line. You'll never get a straight line. So let's go ahead with the next sub question. The next sub question says reading 5 was not taken and use the graph to predict the total volume of NaOH needed to neutralize the total volume of H plus ions at 40 minutes. Now at 40 minutes, what should be the total volume of NaOH? Now understand, we are supposed to calculate the total volume of NaOH, but let's see, look at the graph and find out that at 40 minutes what should be V alpha minus Vt. So here we are back to the graph, and on 40 minutes you can see that the point is somewhere here, and if you find out the point, now we should also draw extended lines from the points on the grid so that it can be shown on the graph that how did we find out our reading. So from here you can find out that the reading is 2.20, but that is V alpha minus Vt. So 2.20 is V alpha minus Vt. So let's see that. So if we calculate from the grid here, see, you can see that our answer here is 2.20. So to obtain Vt, we have to subtract 14, this reading from 14.50. 14.50, if we subtract, we get 12.30. And now how have we obtained this total reading? This reading we have obtained by subtracting the total reading and minus 11.40. So here now we can add 11.40 to get the total reading. Now did you understand how did we do? We had obtained alpha minus V alpha minus Vt by subtracting it from 14.50. So here also we did the same. Now how had we obtained Vt? We had obtained Vt by subtracting 11.40 from the total. So if we want to get the total, we'll have to add 11.40 to this reading, and we get here 23.70. So this is our reading, and this is how we have obtained. So total reading which we wanted to obtain was 23.70. So let's write it here, 23.70 centimeter cube. This is how we obtain the volume of NaO, which we can also show it by writing here as total of 25.90 of both 11.40 and the Vt at 60 minutes, and we can write that V alpha minus Vt reading which was 2.20, and we can write it here and show. Next sub question says it is not possible to repeat the experiment. State whether the data from the experiment is reliable and justify your answer. Your answer here can vary, but here I'll say that yes, the data from the experiment is reliable. I'll say yes, the data is reliable. Data is reliable. I feel the data is reliable. Why? Because all the points lie on the best fit. So I'll write the same reason here as all the points, or you can even write all the readings points lie on the best fit line, we didn't find any anomalous point here, so our data is reliable. So yes, the data is reliable as all the points lie on the best fit line. And so here we end up with this question paper. I hope all the points and all the questions answers are very clear.